All right, so over the past several years, I've been trying to re-implement Tcl HTTPD in something akin to like modern Tcl programming standards, and so basically what we're covered here is why Tcl HTTPD has such a magical place in our heart. Mostly because somebody wrote down how the whole thing works. The new HTTP module in tclllib and what you can do with it. And when you run out of room on that one, that somebody has taken the time to take HTTPD and actually blow it back out into a full-fledged web server-ish, for small values of huge. Well, useful too. Okay, I'm actually running this presentation on a local instance of the web server. If you guys want to follow the slides at home, you can. Actually, my homepage has got the link, and it's actually a bit of JavaScript that I stole from Cayenne. So, see what they're talking about with live demos and wild animals. I'm just kidding, guys. It's working. It's working. All right. So, why do we need like a web server that everybody knows how to use? Oh, web server. First off, I'm going to say that the user interface of the choice in this day and age isn't TK anymore. I know. Burn the heretic! Burn him! Burn! But seriously, guys, Tcl needs new ways of getting information back and forth to the user, and I mean, there are ways beyond a mouse and a keyboard. And newer programs newer platforms are really stressing that you do everything in a browser, especially when you're talking about mobile platforms. But Hypnotoad, you say? We have a host of Tcl web servers, you say? Well, yeah, we do, and that's the problem, is we have a host of them. We've got the huge ones, which are really big and really complicated, and you really need to have a server and a full-time admin to properly administer. Then you've got the little embedded ones, which are basically toys, and as soon as you try to throw anything real at them, you find out exactly what their limitations are. And the few of those toys that do server-side scripting each decide to go off and do it in a completely different way. And there's also the element of, if not everybody's using the same thing, not everybody's finding the same bugs, or different bugs, or maybe the same bugs. But the thing is, if we can get everybody using a system, we can actually test it and make sure it works reliably. Alright, so the HTTP module. I originally started off trying to write Tcl HTTP version 4. And I added coroutines and tcl'2018, and bootstrap and jQuery. And I rewrote the dispatch engine so you can get stuff in and out of there without monkeying in the HTTP namespace. The server's now an OO object, so you don't have to have a dedicated interpreter. And you could load it inside of a normal Tcl program. And it ended up being nothing like Tcl HTTPD. Completely failed on the one job I'd set out to do. But in the end, it was actually pretty nice to use. So if you're going to go use it, if you've got a recent tclllib, you can actually just package require HTTPD and create a web server instance, pick the port, pick the file location, start. And it just works. But that's not all. Now, what people really used to love about Tcl HTTPD was all the direct URL stuff you could do. So I'm going to explain a little bit how the new model works. Or try. So there are three major... So in the old Tcl HTTPD, you used to just hang a proc out somewhere, and the server found it, and the reply was what went out as HTML. There are limitations to that model when you try to do anything serious with it, and anybody who's actually done real applications with Tcl HTTPD ends up having to manhandle the server in really evil ways to get past that model and fix that. So with the HTTP module, what I've done is there are 3 actors that are responsible for getting that open socket into a fulfilled web request. There's a server, a coroutine, and a reply object. The whole process starts off when somebody lights off a socket and opens it up, and you have that little socket-server script going off, and that interacts with the server object. It calls a public method called connect, and it opens it up and starts to figure out what to do with it. The server doesn't do much with it except to spawn a coroutine and give the coroutine, hey, here's a socket, you deal with it. The socket has, the coroutine has some code inside of the server object that tells it how to negotiate the world of MIME and HTTP requests. And the coroutine, basically pulls down all the MIME headers so that it can figure out how to dispatch the reply. And when it's done, it prepares a data structure that describes to an object yet to be created exactly how we're going to answer this request. Yes, sir.
You're talking about the coroutine as if it were an object. It does this and it does this. But what is it? What's the structure here?
Well, it is quite right now at this point in time. It is a coroutine that is this, this construct of the NRE engine that just happened to have been invoked inside of a method for the server, but it has its own state above and beyond that of the object.
So is the state stored in the top level of the coroutine?
Yes. Well, it's not stored yet. We're producing that state. It's going to reside inside of the reply object eventually. Right now, we're building that state and storing it as a dict, as a value.
And the reply object is separate from the coroutine.
Well, it's not really separate. It's how we give the coroutine behaviors to work with. So this is a partnership between 3 objects, or 3 things. And not having been a CS major in college enough to know exactly what you would call that in proper terms.
Are there tcl objects involved?
Yes. So the server object so far is a tcl object, and the reply object is going to be a tcl object, and the behaviors that are going to be mixed in, spoilers, are going to be tcl classes.
So what is the coroutine really doing here?
The coroutine is actually acting as a way to keep everything from going off at once. Because we can bind the coroutine to events, the coroutine only answers events in the order in which it arrives. So if you've ever tried to do socket programming on a serious level, you end up having to do like a state machine. But if things happen a little out of order, or somebody's a little slow, sometimes you can kind of slip past the gears and completely confuse the state machine. Whereas with a coroutine, all of the deep down internally, we're binding to readable events inside of the chan engine, or inside of a file. Okay, the file events as they fire off are triggering the coroutine, but the coroutine will only answer one event at a time in the order in which it arrived.
Okay, so there's a coroutine that is bound to the request response to the session, and then there are these tcl objects that are operating within under the auspices of the coroutine.
Yes.
Okay.
And what the coroutine allows us to do is actually just have the server throw it to the coroutine, and the coroutine takes care of all the error handling, the opening, the closings, and when you're dealing with proxies, it also manages the mess of, I've got 2 sockets. What state am I in? But we'll get there.
Okay.
All right. So we skipped ahead just a little bit, but what we end up doing is, because we need different types of requests to have different behaviors behind them, we create an object which is kind of a deputy of the coroutine, which we can seed it with mixins and behaviors to make a proxy request different than a dynamic dynamically generated content request versus a I'm pulling this file off the hard drive request. That object, there's only one method that the coroutine needs to know to call, and that's a method called dispatch, real original name. And that just gets the name of gets the socket and the dictionary. And from here on out, while it's the coroutine running, all the behaviors inside of the object, the reply object, are what's driving the shell. I'm happy to back up. Yes.
So is it fair to say that this function dispatch is essentially main, analogous to main of a process?
Yes, it is.
Coroutine is the process.
Right. All right. Now, part of that dictionary that comes in are indicators telling the reply object, hey, I want you to pull these mix-ins. And so in between when the thing gets dispatched, we can mix in behaviors, and then there's certain key parts where the dispatch method goes to call a new method inside, which could have been replaced now by a mix-in. And that's how we handle the very different behaviors between when we're doing proxying behavior versus dynamic behavior versus possibly downloading a large file behavior, which all require a different strategy to dispatch it. Okay. And then, once the reply object has finished, it closes the socket, it destroys itself, the coroutine terminates, and there's no sign of anything. It's just the server object left. Okay, I've got some slides where I walk through how to produce some dynamic server content. I have to go back over everything so far, and I've got the papers out, so you can read through this in much more detail. All right, then we'll move on. All right, so the first thing to remember is that figuring out how to dispatch a job is actually the server object's role in all of this. So, as a developer, what you do is you hijack methods inside of the server object to, sorry. Well, that would be handled by simply not terminating the socket. So because we've got a coroutine, the coroutine knows, hey, this is still current events. Unless it's something that's opening and closing, then you'd use a session. But is that roughly what you're? Yeah. So for instance, you could do a WebSocket with this, where the original socket never closes, but we do hand off the control of the socket to the underlying thing. Again, that's the power of having the coroutine minding the shop instead of trying to have some static. Yeah. Were you raising your hand or just? No, scratching my head. Okay. All right. So it's a little awful that you have to modify the object, but I do provide some decent tools so that it's not too painful. So the basic model is the HTTP module doesn't know how to answer anything. You provide that. And so there's a method that is ready for you to hijack, and because it's Tcl 00, you can do that live. And it's called dispatch local. It takes in a data structure, which is basically it's the same stuff you would get with an SCGI process. All of the MIME headers have been squeezed and renamed into that standard. And then you can look through every header there and decide to do anything that you want to do with the socket. So here I'm looking for, is the request URI named demo? If it's demo, then I want to tell it to mix in this behavior that I'm going to create and then return that. If this method returns an empty, then the server just interprets that as this method doesn't know what to do with it. And then the way we implement the basic file server is there's a fallback after this to go, well, can I find it inside the spot where they gave me doc root? Great, I'll do that. Okie dokie. Now inside of HTTP reply, we do things a little differently than the old Tcl HTTPD. If you're, is everybody reasonably familiar with how that used to work? No? All right. It was a system by which you would create a procedure in a rigged spot, and the server would call it. It would make the MIME headers look like Tcl arguments, and the reply would be the HTML that's going out, which, for very rudimentary examples works great, but for most complicated web interactions was a mess. For HTTP reply objects, what we do is we have a variable that we populate called reply body, and whatever at the end of the day is in that reply body gets packaged and sent. And we provide a method called puts, which allows you to pretend like you're an old CGI script and output into standard out, but you don't have to use it. So a very simple demo here is, if you remember back here, we told it you're going to mix in my demo. Well, this is what my demo would look like. It's just a class. You notice it doesn't have any ancestors because we're only providing one method, and that's content. And this simply outputs my header HTML is just a handy little wrapper to just add the opening stanza for your web page, and the footer is the closing stanza. Everything else in between you can populate and know that it's in the right div tag to look pretty. Yeah, and I had a special note. You notice this does not return anything. It's just populating that variable. Okay, doke. Now, doing this and this is a bit janky, so I provide something like what we used to have in the old country. There's a plugin called dit dispatch, and what it does is it provides a dictionary internal to the web server that you can give it host patterns and URI patterns, and it will build the class for you to match that up with the content, so that you don't have to do that stringing together, because most people don't need to write a dispatch engine from first principles. So what will happen here is the first argument here to URI direct is the host, because on a lot of systems you have to handle more than just localhost. And then the second argument is the pattern in the URI, and it will take globs. And so here is the same code that we did before. It's just magically creating that class behind the scenes and doing all of the attachments so that the server knows to attach this class we're creating to the reply. Okay, now next question everybody's going to ask is, okay, how do we deal with forms? There's a method called form data, which does the ugly thing of taking your MIME headers and turning them into a dictionary. So you can just ask for my form data, and you'll get a key value list of everything that either came in on the URI query, or if it was a post request, you'll get the stuff that came in inside the body of the post.
What if it's both?
Well, we'll get to that. So you don't have to use this mechanism, but for very, you're just throwing out an application, this is nice. So here we put a little form on the bottom. We let the user override what the format is for the time. And the other nice thing is if this fails, the server magically creates a 505 internal error report for you. Okay. Now, here's an example of we do expose all of the raw MIME data for those of you who have some real need to manipulate the MIME headers and the post data in your own application. And this is a little bit of the Clay framework, which I'll be talking about tomorrow. But basically the configuration dictionary ends up being written into a data structure that you can interrogate and modify during the object's lifetime. And so the one that we care about in this case is MIME text. And it's basically just a straight dump of in between the HTTP request and the first new line. This is all the text we saw, so that you can manipulate it yourself. Okie dokie. Now in the old HTTPD, you had this magic variable you had to set if you needed to return anything other than HTML. With the HTTP module, your request is available. All the fields in the request are available in a request method, and all the fields in your reply are available in the reply method. So if you want to change the content type, you just change the content type. Okie dokie. And if you really love those old TML files from the Tcl HTTP module, we do support them, but we do it better. It's run inside of an HTTP reply object, so you can invoke that object's methods to get, for instance, your pretty preamble and your pretty postamble. And it still can call the global things if you've got a very large website with all these global templates already populated. Okie doke. And here was a little, one of the things that was very difficult in the old HTTP module, Tcl HTTP, was handling something like REST, where the URI pattern has part of your argument structure in it. Well, with this one, you don't have to worry about that. You just tell it, hey, if something's coming in on REST API, the object will take care of figuring out how to dispatch it. So here we just take the request URI coming in, we break it apart, however we need to break it apart, we make sense of it, however we need to make sense of it, and we reply with it, however we need to reply with it, even if it is making a tail call to something that generates JSON or something along those lines. Okie dokie. Now, the HTTP module as it ships inside of tclllib is more or less designed for, I need to throw a web server into my program, I know what it's going to do, I don't need to do anything else. If you need a web server, the likes of which you can stand up on the internet, there's a parallel project called Toadhttpd. Toadhttpd extends the HTTP module to include a lot of things that are kind of nice to have on a web server. It's distributed separately from tclllib. It's at this fossil URL. It's hardened against botnet attacks. It uses the same plugin architecture as the HTTP module, but it provides a lot of plugins. It has Bootstrap and jQuery integrated, so that when you do the myHTML header, all of those URLs and all of those JavaScript libraries are loaded and ready for you to use. And I have an SQLite-based dispatch engine, caching mechanism, logging, and IP blocking data structure. It handles either being proxied into by SCGI or acting as a host for SCGI processes. And because I needed it, it's got a built-in fossil here. Slides, if you could call them prepared. And if you ever want to play with it, like I said, just open up tclllib and ask for the HTTP module. All right. We had a lot of questions, but does anyone else have questions? Yes.
Maybe not so much a question, but two wishes. HTTP 2. Any plans to support that?
Yes.
Awesome. And scalable WebSockets. So the problem with WebSockets and WebScale is you have a lot of clients connecting, and that typically uses a lot of server resources. It seems that this would be amenable to this, but do you have any plans to allow those channels of representative connections to essentially be put into a paused pool, which just have readable events on them and consume no additional resources on the server other than that? So when something happens, a new request comes from the client, you wake up a thread or whatever is going to be servicing that, presented with this, attach it to that thread, do its thing, and then go back into the pool.
I think we could probably work that out over coffee. Yeah, I'm doing something like that right now with the game engine I'm writing, where it's actually the web server's not answering; it's a thread that's answering it. So basically the coroutine is just sitting there waiting for the thread to respond, but it's not doing it yet. The server can meanwhile take another request. So yeah,
Suppose I want to be delivering back a large stream of data. So something which I'm pulling from some source which is producing a piecemeal, which is going to be delivering, say, a terabyte of data, something like that. I've had such services in the past. The important thing to read is that you've got to be able to stream code work so that it will not store anything more than a few packets worth of data.
So internally, I'm using the chan command to actually pipeline things back and forth. So like when I'm doing the fossil mirroring, once I've decided I'm going to hand that off to fossil, I just wait for the socket to close, and the hands are off. So because you've got you can jimmy the coroutine to basically do anything that you need it to do. Okay, great. But I'll show you the code. Yes.
So maybe I missed it. Is there an example of a handler that has fields in it? And see?
Oh yeah. Well, I mean, let me get the code out. I was just going for simple examples, but I should know you all better. All right. So if we could pop into here, let me make sure I've got this open. Okay. So a great example of that would be down here in the proxy code. And what I'm going to do is just paste this into something that I can actually scale properly. Okay, so these are the proxy handlers, and what we're doing is everything still comes in through the old-fashioned dispatch method, but we provide a lot of extra behaviors. So dispatch starts off, and then we immediately figure out how we're going to proxy the connection, and then we are sitting around in here waiting for the socket to become readable, and we'll just keep, basically we say, hey, when you're readable, come back to us, yield, and it's not even polling. The file event system will wake it up. There's also some things internally with when we're parsing the initial MIME headers. There's some really nasty bots out there that will tie you up in the process of spoon feeding in MIME headers, and so we do a lot of yield. But you know what? If I haven't heard, we also schedule a kill event if 2 minutes have passed and we still haven't gotten the next the next bit of the bit the channel we're expecting. I talk about more of that in the paper. Do you have a specific example? I could show you the fossil.
No, I'm looking for something that's hard to do. Show me something hard to do. Show me something you're solving with the code. So here I'm seeing non-blocking I/O on the socket.
Mm-hmm.
Okay.
Was that?
Anything else?
No, it's just getting it up to this far and getting it regression tested has been the challenge. But I'll have some better examples for next year, I guess. What would you be interested in seeing?
So, I mean, understanding some of the stuff from scalable web servers and other languages that try to do it. You're trying to do thread rapport, and you're trying to do different techniques for handling where you're getting the client to cut up, what they're doing with smaller pieces so they can suspend threads.
Okay, we haven't gotten to that point yet.
Scheming scheduling, right?
Yeah.
Threads are not. We don't want any threads actually. We have 4 cores, we want 4 threads. And I was just wondering if it was inspired by unit stuff and things like that.
I mean, the closest thing I've got is I've written a text adventure where the actual game takes place in a separate thread, and then we're just using HTTPD to get information back and forth from the objects inside that simulation. But it's just a trivial, hey, I spawned a thread, I call, I wait for the thread to finish, I reply. It's not that impressive, but I could show it to you. I think, actually, how are we doing on time? Okay.
Yeah, we're fine.
Okay. Did you?
So we have a lot of high performance servers that have to answer to the water connects quickly.
Mhm.
And our technique is we have pre-forked workers that pass the socket to.
Mhm.
So once we've passed the socket to them, it's from the next connection.
Yeah. I'd like to think we've got the shims for that, but that's something that we have to sit down and actually model out to see if we've thought it all the way through.
This might be a good one to take offline.
Yeah, definitely. Say, Kyan and I are probably going to be working on some. Actually, that was basically his question. So how about you and I and Kyan will meet up right after this and we'll figure it out. Yes.
One of the things with the old HTTPD was when you were processing a TML, you could say that you were going to go off and run some code, and it would then go wait for the user to respond to it and then run some more. The problem was that this led you into re-entrancing problems. And it absolutely definitely would actually trying to do it for more than one user's code. One user's interactions at once. But are you using coroutines with the template processing?
Yeah, you could yield inside of the template.
So that's great, because then that means that all these things can actually interleave with each other, even if you're doing it from the source and all that stuff. And it's just, that's good.
Okay, yeah, so it's a one-trick pony. It's web serving inside of coroutines with a little bit of Tcl'. Way in the back, Joe.
HTTPS.
I want to do it. I don't know how to do it. Please help me. It should be trivial. I have the socket right there, and I know where it's supposed to go. I just am terrible about all the crypto stuff.
Probably have to use like a library to read all this.
Exactly. And I could spend an afternoon figuring it out. I just haven't had that afternoon. But
I'll show you that like.
excellent. Okay. I mean, anything else? I mean, I could show you the text adventure game, but it's just a toy. Or I guess we could. Alrighty. Well, thanks so much, guys and gals.
So people are on your own for dinner. Heck 1. What's yours? Oh, okay. I won't give it away. Okay. Any other questions or comments or anything like that? I'll be opening up 1805 in a couple of minutes. We've got soft drinks, beer, snacks. There will be people going out and eating. For those of you who are not regulars, feel free to attach yourself to a dinner party.
If you need a few recommendations, I just give you my flight work.
Okay. Yeah.
Email.
Okay. And tomorrow morning we start at 9 o'clock.